Okay, so in this video we're going to learn how to solve equations that are not quadratic by making a u substitution that will then make them look like quadratic equations that we already know how to solve. And we'll talk about that. And then the second thing we're going to do is review how to solve rational equations so we can solve shared work problems. But before we get to the shared work stuff, I want to jump into this whole idea of what a u substitution is. So what you see before you is three different equations, and probably equations you've never really solved before. And what I want to do is make what's called a u substitution to make these equations simpler to solve. So before I make that u substitution, what I'd like to do though is go ahead and review that we already know how to solve quadratic equations. There's a number of different ways to solve quadratic equations, but if I have, for example, the quadratic equation x, or let's do u squared minus 5u minus 36 equals 0, and I said solve this. Hopefully by this point in the semester everybody would be able to do this. We've talked about a number of different ways to solve quadratics. You could factor, you could complete the square, you could use the quadratic formula. Hopefully you notice though that with this one that this is pretty easy to factor. So if we were to go ahead and factor it, we could factor this to u minus 9 times u plus 4, which then means u minus 9 has to be 0 and u plus 4 has to be 0, which means u has to equal 9 or u has to equal negative 4. So there's really two different values for u for that particular quadratic equation, and this is something we already know how to do. Now let's jump back to our three problems listed above here. Each one of these, like I said, before was not a quadratic equation. However, if we make a u substitution, what I'm about to show is that they will become equations that are exactly like this one we just solved, that we know how to solve. Notice that all three equations are equal to 0, equal to 0, equal to 0, equal to 0. Notice they all have a c term of minus 36. The second term, they all have minus 5 as the coefficient, or the number in front of the variable part. And then the coefficient on the first term is 1 for all of them. So in the first equation, and whenever we're doing u substitutions, to decide what to make u, we always use the middle term. And the middle term, the part that comes after the coefficient. In this case, it's a coefficient of 5. So in order to pick our u, we pick u by looking at the middle term. So in the first problem, we want to let u equal x squared. In the second problem, we want to let u equal square root of x. And in the third problem, we want to let u equal x minus 2. Because if this is u, and this is u, and this is u, then the middle term of those equations becomes minus 5u. The minus 36 won't change. Same thing in this equation. It becomes minus 5u minus 36 equals 0. And then again over here, minus 5u minus 36 equals 0. Because when you substitute, all you do is you take one quantity and replace it with another. And if I let u equal x squared, then this x squared can become u. So instead of minus 5x squared, we have minus 5u. Now, all these equations are still missing the first term. But what you should notice, though, is that we started out here in this first problem with u equal to x squared. Well, then what is x to the fourth? Well, we know that x squared times x squared is x to the fourth. But x squared is u. So x squared times x squared is really the same as u times u, which is u squared. So instead of x to the fourth, if I want to put it in terms of u, that's the same as u squared. Same thing for the second problem. I have square root x here, but I want x. Well, isn't square root x times square root x equal to x? But square root x is equal to u, so instead of square root x times square root x, that's the same as u times u, which is, of course, u squared. Hopefully you're starting to see the pattern here. So we have u squared minus 5u minus 36 again, and again, with the last problem, if u is x minus 2, then x minus 2 squared is the same as u squared. So all three of these equations, with a simple u substitution, actually get turned into the same quadratic equation in terms of u. And we already solved this equation. No matter which equation it was, we got the same answer. We got that u is equal to 9 and u is equal to negative 4. What we got to remember here, though, is these answers are in terms of u. We want to solve now. This is solved for u. We have one final step here. We need to now solve in terms of x, which we're going to see here is not that difficult to do. So the way we put it back in terms of x is we use the u substitution that we made at the very start of the problem. So in the first problem, we let u equal x squared. Alright? But, it's a 9. We let u equal x squared. But what's u, though? Well, u was two different answers. U is equal to 9 and u is equal to negative 4. So I'm going to take that substitution, and now I want to back substitute. So I want to take 9 and set that equal to x squared. And here I want to set negative 4 equal to x squared. Again, I just want to reiterate that we took the u values we had here and we put them in place of u. And once you've done that, we now just have to solve that simple equation in terms of x. We don't quite have x by itself yet, but this is the type of equation we've been solving. To get x by itself, we just square root both sides. So we take the square root of x squared, and we take the square root of 9. Of course, we know when we take the square root, that gives us two answers, a positive and a negative. So this gives us plus or minus 3 for x. Same thing on the other side. Here we have plus or minus square root of negative 4 equals the square root of x squared. We know that if we square root x squared, we get x. The square root of negative 4 is 2y. So here we have four answers for this problem. We have negative 2y and positive 2y. We have negative 3, positive 3. So this is our answer to the first problem. The second problem, we again are going to use our substitution. For the second problem, right here, we were given that u is equal to the square root of x. And we're going to now again back substitute with our u values that we found in the middle. We know here that 9 has to be equal to square root x, and negative 4 has to equal the square root of x. Notice it's the same two u values that we're just plugging in for u. Now to solve for x here, we have to do the opposite of what we did the last problem. The last problem, we took the square root of both sides. Here, to get rid of the square root, we have to square. So we're going to square the left side, and we're going to square the right side. When I do that, the right side becomes x, but the left side becomes 81. Same thing on the other side. If I have here negative 4 squared and square root x squared, the right side becomes x, the left side becomes 16. Now, one thing that does complicate matters a little bit here with the middle problem is that because it's a problem with the square root, we need to go back in and check our answer in the original equation. This one up here, x minus 5 square root x minus 36. So we have a check here. We need to check in our equation. It was x minus 5 square root x minus 36 equals 0. If I check x equals 81, this becomes 81 minus 5 times the square root of 81 minus 36. This is 81 minus 5 times 9, which is minus 45, minus 36. That is equal to 0, so that one's okay. We should also, though, check 16. That gives us 16 minus 5 times the square root of 16 minus 36, and you can see there's a problem right here, because this becomes 16 minus 20 minus 36, which is definitely not equal to 0. So that answer we're going to cross out. So our only answer is x equals 81. And anytime we have an equation that has square roots in it, there's always a possibility that we can get one or more extraneous answers out of our originals. Okay. Moving to the last equation, again we're going to use our substitution that we made. In this case it was u equals x minus 2. And we are going to again plug in our u value. We found that u is equal to 9 and that u was equal to negative 4. And to solve both of those for x, we just have to add 2 to both sides. When we do that, we get x equals 11 and x equals negative 2. Okay, so this is how we solve equations that are in quadratic form by making a u substitution. Hope that made sense. We'll move on to the next topic. Second topic is doing the work-related problems, shared work. And to be able to solve these, we're going to need to remember how to solve an equation, an irrational equation. You remember how to do that? You have to multiply by the least common denominator, which we should probably factor the bottom here. If we factor the bottom, we get x minus 4 and x plus 3, which happens to look like these other two denominators right here. So our least common denominator in this case is that most complicated one. It's the x minus 4 and the x plus 3. To get rid of this right-handed denominator, we need to multiply by x minus 4 and x plus 3. And the rule with any equation, if you multiply one piece by something, you have to multiply everything by that something. And then all our denominators cancel when we multiply. You've done this before. I just wanted to remind you what it looks like. Let's now take a look at a application problem. So these are the shared work problems, also called work rate problems. And they have to do with what happens when you solve a problem that has two different things sharing work. When you have maybe one person that can paint a house and another person that can paint a house, and how much faster the job happens when the two people work together. It has to do with that sort of thing. So this first example has to do with a pipe. It says a small pipe takes 40 minutes longer than a large pipe to fill a tank. If both pipes are working together, they can fill the tank in 75 minutes. How long does it take the small pipe alone to fill the tank? And the idea here, the idea that we're going to work with in this problem is the idea of what a rate is. How do you calculate a rate? A rate is how fast you can do something. And my example I always like to give here is, if it takes me 5 hours total to paint a room, 5 hours total to paint a room, how much of the room has been painted in 1 hour? If it takes 5 hours total to paint a room, how much of the room has been painted in 1 hour? Well, each hour, a fifth of the room would be painted. So the answer to this question is 1/5. And that's how we find a rate, especially for these type of problems. The person that's doing this painting job can paint 1/5 of the room per hour. That's a rate. So we're going to define rate to be equal to 1 over the total time. And so the way they usually work out is you take the rate of the first person or pipe or whatever, and you add it to the rate at which the second pipe or person can do the job, and you get a combined rate. And there's two rates working together, can be added together to get a combined rate. And so let's see how we can apply this with the problem in the example. It says a small pipe takes 40 minutes longer than a large pipe to fill a tank. If both pipes working together can fill the tank in 75 minutes, how long will it take the small pipe to fill the tank? So the idea here is going to be the rate of the small pipe plus the rate of the large pipe equals the combined rate. And remember, rates are always this form. They're always 1 over the total time. And we don't know the total time for each of these individually. We do know, though, that when the pipes are both on and working together, that the total time is 75 minutes. So the rate then would be 1/75 per minute. And that these other rates are always also going to be 1 over something. So the question comes, since we don't know either one, how are we going to use one variable to define both unknowns? Well, we should probably let x be the variable that we're solving for. So when this problem, when it says how long does it take the small pipe to fill the tank, we're looking for the time of the small pipe. So I would think it would be best to let x be here. And since the smaller pipe takes 40 minutes longer by itself, then that means the larger pipe's time is x not plus 40, but x minus 40. It's 40 minutes less time than the small pipe. And so this is our equation. It's 1 over time plus 1 over time equals 1 over total time. And we now know how to solve something like this. We want to get rid of the denominator. And our LCD for this problem is going to have to include all three denominators. It's going to need a 75, and it's going to need an x, and it's going to need an x minus 40. And because we need all three different denominators to get rid of these three different denominators. And so I'm going to multiply by 75x times x minus 4, 75x times x minus 4, and 75x times x minus 4. And then we're going to go about canceling what we can cancel. So in the first term, the x's cancel, and then the x minus 40's cancel. That should be, just notice that should be an x minus 40. So in the second term, the x minus 40's cancel, and then the last one, the 75's cancel. And so we multiply, we have what's left. In this first term, we have a 75 and an x minus 40. In the second term, we have a 75x. And then in the last one, we have an x times x minus 40. Okay. And we want to distribute, so we have 75x minus 75 times 40, which is what? $75 times 40 is 3,000 plus 75x equals x squared minus 40x. And now we say, it's a quadratic, so we got to get everything on one side. And we know that the left-hand side becomes 150x minus 3,000. So I want to subtract 150. And add 3,000. Which gives us x squared minus 190x plus 3,000. I already have is equal to 0. Okay, and so that could be factorable, but it's such a big number, it's probably not likely that it is, or if it is, it's probably a lot more work than is going to be worth it. So this would probably be a good example where we solve using what method? Hopefully you said the quadratic equation, because quadratic equations always work. So this would be x equals negative b, so positive 190 minus 4 minus the square root of negative 190 squared minus 4 times 1 times 3,000 all over 2 times 1, which is 190 plus or minus 100 minus 12,000 over 2, which is 190 plus or minus square root of 24,100. Which is 190 plus or minus about 155.2 over 2. Which really gives me two answers. It gives me the first one if we add them. So if we take 190 plus 155.2, divide that by 2, we get about 172.6 minutes. And then the other one we subtract is 190 minus 155.2 divided by 2, which equals about 17.4. Now, one of those is not reasonable because my large pipe time has to be 40 minutes less than the small pipe. So how can I be 40 minutes less than 17.4? It's not possible. That answer is not logical. But then and how can the 17.4, the time of the larger pipe, be, or the smaller pipe, be less than the total time of 75 minutes? Because that should be faster. So the more reasonable answer should be this 172.6 minutes. That's the time it takes for the smaller pipe to fill the tank all by itself. Alright? So there's a shared work example. Let's go ahead and look at one more of these. It says, working alone, Gabe can clean the gymnasium floor in 15 minutes less time than it takes Rob. If both janitors work together, it takes them 45 minutes to clean the gymnasium floor. How long does it take Gabe, working alone, to clean the gymnasium floor? Round to the nearest tenth of a minute. So let's go ahead and read this one. Working alone, Gabe can clean the gymnasium floor in 15 minutes less time than it takes Rob. If both janitors work together, it takes them 45 minutes to clean the floor. How long does it take Gabe, working alone, to clean the gymnasium floor? And so we're going to take, just like the last one, we're going to take the rate of Gabe. We're going to add that to the rate of Rob, which should give us the rate together with both of them working. Remember, this looks like 1 over some time plus 1 over time equals 1 over time. And I want you to just go ahead and think about this for a second. Pause the video and ask yourself, what goes in those denominators? Okay, so you took some time to think about it. I hope you were able to come up with something. Notice that it says here in the problem that it takes them 45 minutes to clean the gymnasium when they work together. When they work together, it takes them 45 minutes. So that's the time for the together, when they're working together. So this is going to be 1 over 45. And then we want to find how long it takes overall. It takes Gabe. So we want Gabe to be time X. And since Gabe can do it in 15 minutes less time than it takes Rob, Rob's the slower person, then Rob's time is going to be X plus 50.
So again, we should be able to solve this problem. What is the LCD? Pause the video for a second and write down what do you think the LCD is going to be. Okay, I hope you took the time to pause the video and write down what the LCD is. I think that the LCD in this case, again, should include all three denominators. It needs the 45, it needs the x, and it needs the x plus 50. And so what are we going to do? We're going to multiply everything in this equation by that LCD. And I'm not going to finish this problem. I will give you the answer, though. I want you to go ahead and try it on your own. So the answer is, it takes Gabe 71.5 minutes to clean the gym floor by himself. You should be able to get that answer. Alright, thanks for your time. We'll see you in class.